what we have here are integrals with trigonometric functions in them, usually sine and cosine or tangent and secant. Now, what I've said or stated in the previous tutorial is that the first thing that you want to look for is, could you make a u substitution? Not yet. Could you do integration by parts? Well, not really. You'll have to use trigonometric integrals. Now, another thing that's different from my previous tutorial is that both sine and cosine have even powers. If one of these were odd, then it'd be much easier. You would just have to break apart the odd one into something like this. So like in algebra, we learned that x cubed equals x squared times x. Same basis, you add the exponent. That's 2 plus 1 is 3. But in this case, we have both even powers. So what to do in this case is, first I would, for tutoring purposes, I would rewrite this as the integral from 0 to pi sine squared x times cosine squared x quantity squared dx. And now it's more apparent that whenever you see like sine squared or cosine squared, always use half angle identities. And this may be a little review from trigonometry. Here's how it goes. Sine squared x, that equals 1/2 times quantity 1 minus cosine of 2x, which is the same thing. You might have seen it like this, 1 minus cosine 2 of x all over 2. It means the same thing, but I prefer it like this. It's easier for me to memorize. You'll find out in a second. Cosine squared x, the half angle identity, is 1/2 1 plus cosine 2 of x, which of course is 1 plus cosine 2 of x all over 2. Okay, and the reason why I like this is, now people have their different mnemonics. I'm sure that my mnemonics may not get through to every single person, and you might actually have something better which is just best for you. Here's how I think about it. When I know that I have to use half angle identities, the first word is half angle identity, so I just put a half. The only difference between this is the sign. So if you could just memorize that, first what you do is you put half and then you multiply it by the quantity 1, leave a space, cosine of 2x. Now for sine it's going to be a minus. For cosine it's going to be a plus. Think about this. Here you have cosine and cosine on both sides of the equation, and that's a positive thing, right? If both sides have the same thing. Sine and cosine, you have different things. There's a difference there. Difference and subtraction. And we have a minus sign here. So that's just one way that I memorize it. Either way, you have to memorize that this becomes the integral from 0 to pi. Now I'm going to make a substitution here, and this becomes 1/2 times the quantity 1 minus cosine of 2 of x times, now I'm going to make a substitution here, that becomes 1/2 times the quantity 1 plus cosine of 2 of x, all quantity squared dx. And then and then I'm going to set this equal to, I'm going to go ahead and square this, and that equals the integral from 0 to pi, the definite integral from 0 to pi, 1/2 times the quantity 1 minus cosine 2x times, this becomes 1/4 times 1 plus cosine of 2 of x quantity squared, okay, dx. Now 1/2 times 1/4 is 1/8, and I'm going to pull that constant out of there, that constant multiplied to these, and that becomes 1/8 times the integral from 0 to pi, okay, times the quantity 1 minus cosine of 2x. Then I'm going to square this. I'm going to go ahead and remind you, you might already be a master at this by now, but if you have a plus b squared, that's the same thing as a squared plus 2ab plus b squared. Okay, whereas a is 1 and b is cosine of 2 of x in this case. So that's going to equal 1 plus, okay, that's going to be 2 cosine of 2x plus cosine squared of 2 of x dx. Okay, and now I'm going to multiply this, or FOIL this. That's going to be 1/8 times the integral from 0 to pi. 1 times 1 is 1. Okay, plus 2 cosine 2 of x plus cosine squared 2 of x minus cosine of 2 of x minus 2 cosine squared of 2 of x, cosine times cosine, and we have the same 2 of x inside, and then minus cosine cubed of 2 of x. Don't forget the d of x. So then I'm just going to combine like terms here. Now first notice that you have cosine of 2x and a cosine of 2x there. Here you have a cosine squared 2x and a cosine squared 2x here. So I'm just going to combine them. So this equals 1/8 times the integral 0 to pi 1. Now 2 cosine 2x minus cosine of 2x. 2 minus 1 is 1, positive 1. 1 minus 2 is negative 1. And then you have cosine cubed 2 of x dx. Now for tutoring purposes, I'm going to just like distribute this integral sign all the way across. So I have 1/8 times the integral from 0 to pi dx plus the integral of 0 to pi cosine of 2x minus the integral from 0 to pi cosine squared 2 of x minus the integral of 0 to pi cosine cubed 2 of x, and do not forget the dx like I momentarily did. Okay, and plus I was running out of room anyway, so this equals 1/8. Now let's just tackle this one first. The integral of dx, that's just going to be x. Okay, and that's integrated from, again, 0 to pi. We're using the fundamental theorem of calculus part 2 here, and then we add this to cosine of 2 of x dx. Now what is the integral of cosine 2 of x? Well, it's going to be 1/2 sine of 2 of x, and again that's integrated from 0 to pi. How did I know that? Well, first, if you're unsure, just take the derivative. The derivative, and I'll just work on the side real quick about for that. The derivative of 1/2 sine of 2 of x equals 1/2. Now the derivative of sine of 2 of x is cosine of 2 of x times chain rule. The derivative of the inside function, the 2 of x, is just 2. That cancels, and you're left with cosine of 2 of x. Therefore, the integral of cosine of 2 of x is 1/2 sine of 2 of x. Now let's go on to here. These are when we start to have like multiple steps for this. So we subtract this by the integral from 0 to pi cosine 2 or cosine squared of 2 of x dx. What should we do here? The half angle identity again. But recall that the half angle identity for cosine squared of x equals 1/2 times the quantity 1 plus cosine of 2x. Now, if this is multiplied by some way, if this was cosine squared of 2 of x, if x is multiplied to 2, then you would have to multiply this by 2, which would be 4. So, in this case, the half angle identity right here would be, now I'm not evaluating the integral yet, I'm just simplifying the integrand to make it easier. It's the integral of 0 to pi times 1/2, I'm just going to put that outside here, times 1 plus cosine 2 times 2 is 4 x dx. Now again, I'm evaluating this part right now, or more like simplifying this part right here. Recall that, or remember that this is cosine squared of 2 of x, so you have to essentially double this right here, so it's cosine of 4 of x. Don't forget that. And then we subtract that by the integral from 0 to pi. Now for this, you have to separate this, referring to up here, expand it out, and say that this equals cosine squared of 2 of x times cosine of 2 of x dx. Now what you do is start back over here. That's 1/8 times, that's pi, minus 0, which we don't have to write, plus 1/2, now that's sine of 2 pi, minus 1/2 sine of 2 times 0, which is 0. And if you recall the sine graph, here at 0, sine of 0 is 0, sine of 2 pi is 0. So this basically goes to 0, and this goes to 0. So we don't have to worry about that. And then that's subtracted by 1/2 times the integral of d of x is just x. I'm going to put a parenthesis here. So the integral of d of x is just x, evaluated from 0 to pi. And then that's added to the integral from 0 to pi of cosine of 4 of x. This equals 1/4 sine of 4 of x. See, the integral of cosine 4 of x is sine of 4 of x, and then just bring down that 4 right here, and then that's integrated from 0 to pi. Okay, I put the parentheses here because that's minus 1/2 times both of these. Okay, and then that's subtracted by this. Now what you want to do here is make another substitution. We're going to be using the Pythagorean identity, and that's pretty much the purpose of like first breaking this up and everything, because you can't use the u substitution just how it is. You need a sine and a cosine. Recall sine squared x plus cosine squared x equals 1. How do we get cosine by itself? We subtract sine from both sides. Well, sine squared from both sides. Okay. So this equals the integral from 0 to pi 1 minus sine squared. Now recall that this is just sine squared x plus cosine squared x. When you have 2x in here, this will become 1 minus sine squared of 2 of x right here. Okay, times cosine of 2 of x dx. Now we could use a u substitution here. First, let's go back over here. So this equals 1/8 times pi minus 1/2 times, that's going to be pi minus 0, which we don't have to write, plus 1/4 sine of 4 pi minus 1/4 sine of 4 times 0 is 0. And of course, recall that this is 0. And if we would keep on going, we would note that sine of 4 pi is also 0. Okay? And so that takes care of this. And then we subtract it by that. Now, we let u equal sine of 2 of x. Du, therefore, will be the derivative of sine of 2 of x, which is cosine 2 of x. Now, note that we have to use chain rule. The derivative of the inside function 2 of x is 2. And don't forget the d of x. Now, we have a cosine 2 of x dx right here, but not 2 cosine of 2 of x dx. I'm going to divide both sides by 2. It's going to equal cosine of 2 of x dx, which is what we do have right there. Okay, so we subtract it by the integral. Now notice very carefully, these bounds are in terms of x's, not u's. Okay, and it is a big deal, and my calculus professors were extremely strict on that, and of course I agree, because if we go ahead and make the u substitution and retain these bounds, it's completely different. We have to change the bounds, or you could do side work, like evaluating this with u substitution, using an indefinite integral, then substitute back in for x's, and then substitute back in here. Or you could just basically make it relatively easier and just change the bounds. What happens when x equals pi? When x equals pi, u will equal sine of 2 pi, because we substitute pi in for x. What do we know about sine of 2 of pi? It equals 0. So that's the upper bound. Okay, we substitute pi for 0. Now when x equals 0, okay, u equals sine of basically 0. 2 times 0 is 0, which we know is 0. Now we don't have to really go on from here, because something that we learned from Calculus 1 class is that if you have the integral from a to a f of x d of x, it's going to equal 0. Okay, because if you have the graph and you have some function and you're just going from a to a, basically nowhere, you basically have a line. You cannot find an area with just a line because it doesn't have a width. To find area, you need like base times height, or in this case a width times the height. You just have height here. You can't find an area with a line, is basically what I'm saying. So this whole thing goes to 0, and guess what? No, I am not joking. After all of this, what we're left with, this equals 1/8 times pi minus, I'll go ahead and distribute that, pi over 2. And of course, you should simplify, make it look nicer. Okay, get common denominators by multiplying 2 over 2. Now we have the common denominators. Simple 5th grade math right there. Okay, and that is the answer. That is the answer. But of course you had to prove it to yourself, go through all of this, and besides, it's very good practice, and you build you build almost an infinite amount of concepts right here. Okay, not literally, but this is basically what it takes for these types of problems. Again, if one of these were odd, it'd be a bit more simpler than this. So again, so just take it slow sometimes, especially when learning new concepts, and especially at first when you're going through these yourself, and why you're taking this class, what your major is. If it's truly in your heart, just don't give up on them. Never give up on your passions, and have a nice day.